very much. It's good to see so many people here. Yeah, let me start with a short pre-flight check because we are attempting a high-altitude flight over the land of LLMs and retrieval augmented generation. So if you feel dizzy, that's perfectly normal. If you need to leave, the exit is at the... No, that's what was too short. Wait. The exit is over there, and you can probably open that one as well. Yeah, I'm trying to keep my talk as understandable as possible, but you can never be sure, so I would like to agree on some safety signs with you. If I'm talking about something that you just don't understand, or if I use words that you don't know, please do this gesture. Okay, and if I'm repeating myself, then do this one. And if I'm saying something weird, then say, you don't have to repeat that. Okay, who here has played with ChatGPT already? That's probably everyone. Who's using Cursor? Who's allowed to use Cursor at work? Sometimes. Who's not allowed to use Cursor at work? Sometimes. Okay, and who here has done some retrieval augmented generation already? Okay, great. Who knows what retrieval augmented generation is? Yeah, okay, that's increasing. That's very good. Who has played with a blog post on our BitCrowd website about retrieval augmented generation? Yay! That's totally great. Was it okay? Okay. Let's start. I'm Chris. I'm founder of BitCrowd. We're building Elixir applications. We can also help you with your machine learning project. And we also help you with your development setup. That means in terms of tooling, processes, or development itself. And from this help with development setup, there is also the idea to this talk. But it's called Why You Want RAG on Your Dev Setup and How You Can Do it in Elixir. The agenda is my motivation, or why we even bother to talk about this. Some retrieval augmented generation basics, and some RAG tuning for code bases. You can also do like if it goes on. Motivation. Imagine it's your first day on a new project, and you come to work, and you finally got your coding buddy, and you've got access to your to the ticket tracker, and you want to start coding, and you just take the topmost ticket from the tracker, and it sounds like skip sending appointments reminder email for appointment where attendance is not required. Oh dear. This is clearly meant for someone who knows the application already, because like it offers us no context and it does not show us anything that we can go with. So we can either put that silently back and take another ticket, which ends when we've shuffled down all the tickets once through, or we can wait for our coding buddy, but she's busy over there, so we could also dive into the code base ourselves, but maybe that's unnecessary complicated or might take unnecessary complicated time. What if there was another option? What if we had a local RAG system, retrieval augmented generation system, that we can actually ask things about our code base and that would answer? For instance, here it's proposing us to make changes in the enqueue appointment reminder that's cut off, and also explains us some things, what we could change or what we could have a look at. But while we were looking at this and while we were just about to edit the ticket description in order to ask our coworker if we understood that correctly, someone else has grabbed the ticket. And when we look in there, oh, yeah, it's the wrong screenshot. I have the system running. You can have a look afterwards. It actually matches the files that were changed. If you have played around with RAG before, or especially if you have played around with RAG on code bases before, you might have seen that often they produce quite great results. In fact, one of the secret recipes of Cursor is that in the background, in its default setting, it's doing RAG on all your system, on all your files. You see here, it's like quietly uploading the embeddings up to their cloud, and it's also analyzing your Git history to find out like how things match together. And that is actually one feature that Copilot is missing, because Copilot often only looks at the current context that you're editing, and that Copilot does much better. Cursor does much better. But you don't need to use Cursor. You can also just use this small blog post. You can actually copy that QR code. It's a little, like, whatever. It's a set of scripts, and you can try that out. It's meant to give you, like, the first idea. Actually, if you're watching that at home at the tellies, you should use the occasion to press pause now and check that out and play with it so you can know what we are talking about. Yeah, why am I pitching this to you so hardly? In our practice, we find that many teams struggle with information distribution. Often the people that know the code base best actually spend the least time with coding, and most of the times they talk to other people and explain tickets to them, or do ticket writing, or answer questions, or pair on things. And so the other developers are sometimes queuing up, waiting for those people to become available. And so there is a hold up there, which becomes apparent, especially when we're doing onboarding. Okay, so what is retrieval augmented generation? You've probably all seen a graphic like this. It's an LLM that tries to make sense of the context as it has and the training that it has, and it computes the probabilities for the next word. It tries to find the solution that makes just about sense to get away with. But I only understood where hallucinations come from when I was trying to watch Star Wars with my youngest son. We were looking forward to this like weeks, and it was okay, it was cleared and everything. We were sitting on the sofa, and we were just like 10 minutes in the movie when he said like, stop. What? Stop. Are you frightened? No, it's the wrong story. What had happened? In their kindergarten, no one had seen Star Wars before, but everyone had like a small bit and piece of the movie. And when I later picked him up at one point, they were trying. I witnessed how they were trying trying out those stories at each other. Like, no, that doesn't make sense. He's like this. No, he's like more like that. And so they were having a huge discussion about that. And they arrived at the story, or my son arrived at the story, that it's like completely different. And I loved to see them like work their way through what they know. and the results that they come up with. So that's a bit why an LLM is hallucinating. If you don't give them, they have this thing that's called context. It's like the seed that they use when they try their probability game. And if you don't give them information in the context, if they only go for the chat content of the chat that you're currently in, then they just take the bits and pieces that they have in their training and what they might have understood. And then you arrive at whatever, something that is at best Star Wars-y-like. So if we wanted our children to tell us better stories about Star Wars, or stories that match the reality a bit more, we would need to, for instance, we could train them, we could reward each thing, each sentence that matches Star Wars a bit more. But you might see that this is this might work at some points, but not at others. They just don't have enough to go for. If we really want them to tell good stories, we would need to engage the people at the kindergarten to read them Star Wars books. It's a bit like telling someone a movie that you've just seen. You have it all in your context, and so you can tell a better story. The fewer you have, the wilder the story is. So what we're doing with retrieval augmented generation means we're retrieving a piece of information from the internet or from a file or from wherever, and we're enriching the content so that when it starts to generate the answer, the probability of having an answer that actually makes sense for us is quite high. For that, we retrieve, and when we're looking at our code base, we want to retrieve the data from we want to make a representation of the code base in our mental model of the application, which is, hey, wait, not so fast, which is a vector store like this. So, RAG tuning for code bases. When you want to train your RAG to improve, then you should have like some kind of lab set up. We use text chunker from Elixir together with Python from LangChain. With Python, we needed to add the Elixir support, which got merged quite quickly. And the results between those both were basically the same. It's not so surprising because the recursive character text splitter, the Elixir version, is basically a re-implementation of that strategy. For the LLM and the embeddings, we used Ollama AX, and after some experimenting with everything that was available on Ollama, Ollama is something like a package manager for models. After we tried out everything that was available on Ollama, we settled for Gina AI because that was the only embedding model at that time that yielded a performance that was close to the models of OpenAI. And we are using Llama 3.2, which is actually quite a small model which runs on my machine without any problems. And of course, you need a vector store. We use Chroma because Chroma is building up on SQLite, which is just a file-based database. And that's quite good if you want to experiment with different stages of the database. You can just copy the files around until you arrive at something sensible. It's good to measure improvement. And we've seen, if you still have this image of how RAG works in your head, then you see that there are many stages to that. You have the retrieval part, you have the prompt, you have the generation part, and we are just focusing on the retrieval part because that's the part that we can measure easily, and finding like a good LLM or finding a good prompt is like something that everyone can do easily. So how do we measure our improvements? We took our Git history and took the latest commit, and then we moved the whole file system one commit back, and then we started our ingestion. And then we pretended that the change did not happen, but instead we gave the current commit message. What came out of that is that we could compare the files that were changed with the files that were predicted. So we arrive at something like this, where the most right column shows which files were correctly predicted. The first one shows the files that were only in the pull request, and the middle column is the files that are only in the prediction. For instance, in the first row, we see that the prediction was entirely bogus, like we did predict anything. This is a crude metric. It might well be that those files are correct or a good place to look at if you solve the ticket. But so when you use something like this, you can make a fast turnaround and then optimize large bits of your ingestion cycle before you progress to more sophisticated methods. So this is the initial state, and the next improvement for that would be to add file headers, because rag on code is a bit different from rag on files, because if you retrieve a PDF document or retrieve information from a PDF document, you're actually interested in the information. Who was the president in whatever day or something? You would just want the information in your context. But if we are doing rag on code, we also want to know which files are we looking at. And that is an information that normally is not included in the chunk. It's just the document itself. So if we add a file header with a file name only, or even a small header about what the file does, and if we inject it to every chunk, we get a better performance. And we also get the capability that the system answers questions like, which files would I need to change, or what would I need to do? And the last, sorry about that. And the last hack is adding PRs and files changed. Like if you take the information like about the previous commits and add them as documents, then the vector store has the embedding model has the possibility to get connections between the files. So with that, you arrive at a better performance. And these are like the low-hanging fruits, and it's really worth it to experiment with the ingestion of that. And from that, you can do like more advanced techniques like rewriting or re-ranking the results so that they make more sense to you, or for the LLM. Or you can try to rewrite the messages that go to the retrieval so that they match more what is in the store. Wrap up. Local setups are quite powerful. If we have like some minutes time left in the end, I would also do a demo. They can run on a local server. You don't see that it's like a MacBook, whatever, and it's reacting quite well. They can integrate well into your DevSet environment. You can use Slack or whatever, or GitLab or whatever you want. And for one huge advantage is that you can use the whole thing to train the model further, because if you take this metric that we already have looked at, then that's something that you can use as training data already. Like, this is the question, these are the chunks, that is what you should have gotten. I don't want to talk about that. What next? Watch out the BitCrowd blog post. We will release more blog posts on this ingestion. We will release another blog post on how to do it in Elixir. That's a missing link at the moment. And we are also starting the work on a RAG library so that it's easier for you to include RAG in your applications. Yeah. Try out the code. And if you get stuck, give us your problems. Like if you have a large code base, we would really love to optimize on that. If you want to improve your code quality or documentation, we also do setup workshops where we come to you and show your developers how to set up and what is more, how to elaborate on the setups that you have. So you not only get a living documentation of your code base, but you also get the knowledge to transfer what you have there into the modern AI technologies. Isn't that a nice word, ending? Yeah.
All right, so we have about 10 minutes left. So would you like to answer questions first, or would you like to do a demo? Would you like to see a demo?
Yeah.
Yes? Demo? Okay, cool. Let's do a demo. If you
What
want to.
have I done? Okay, here's actually the file that I wanted to show you. You might remember that we were asking, like, we had like this thing here, skip sending appointments reminder for email appointments where attendance is not required. No. So, and it tells us a lot of things, and then it proposes us the changes that we should make. And you might be asking, what is that for an application? And maybe we ask, what is IDA? And it says, however, based on the provided context, it appears that the project from Charité, there is IDA backend. There's an IDA backend app mentioned. That's actually the LiveView Phoenix application. It seems that IDA might be related to medical or healthcare content. And it also shows us here on the, I need to make this, look this code, look this description here. I need to go leave full text. So maybe like this. No, the formatting is a bit off for some things. Or maybe, oh no, I shouldn't reload. No, I'm in a note. Do you have a question that I should ask it?
So when you're doing the preparing the text to save as an embedding, so you have like a full module or your code, and you want to create embeddings. How do you split it? I mean, the kind of, how do you tokenize it? Do you choose, because for a book you choose phrases, paragraphs. How do you split it with code? How do you decide to?
Great question, actually. When you explore LangChain or when you explore text chunker, they only add new lines at class or module frontiers, and then the chunker, which is the part that splits the files, only looks like where is a paragraph or where not. So that means all the ingestion models that we all the ingestion code that we have somehow assumes that text code is text in some way, so it just doesn't make any meaning. There are also techniques which do like abstract syntax tree transformations to make infer more meaning, but actually I haven't looked into that because, strangely enough, this already makes sense, like you've seen. Yeah.
Where to look for AST trees, actually, how it works with them, because that's super interesting topic.
Yeah, I don't have that in my memory, but we can exchange. Like I found that somewhere. We can talk afterwards after that. Mm-hmm.
Do we have more questions? Yes.
Could you ask the system where it sees the most potential for refactoring?
Actually,
that would be a good one to now try. Yeah. If you want to.
Sorry? Where do you see the most potential for improvement? Okay, refactorings. What do you expect to happen?
Finding some code duplication and making suggestions about how to generalize that.
Yeah, I actually never asked a question like this, so I'm curious as well. But what I think will happen is that we might not get a good answer because, like, our system is set up to retrieve something from the vector store and toss that into our context. So it might know what does it have to. Is it able to pick on? It has potential refactorings. And the rest is probably garbage. So let's see. I would expect that we find maybe a pull request. Actually, if you connect that to a Slack, then it's much better because you kind of expect that Slack has some lag in here. Highlight areas where refactoring could be beneficial. Okay. Oh my God. What have I created? It also gives us here the things at the chunks that it has found. I think we're almost finished with our time.
Yeah, I think there's one question from the Hoover app. Have you thought about implementing a sort of reinforced loop and provide examples of good and bad predictions? And would that make sense to you?
Yeah, that's what I proposed in the other slide. Just taking this metric that we have and like enforce that. If you go to, for instance, the Gina AI website, it shows you exactly how you can how you can train those embedding models. And it's actually because those models I need to speak faster because the time is running out. Actually, those models are quite small, so you can run them on your normal hardware. You don't need a beefy machine or anything.
Okay, nice. Thanks again, Chris.